Yes, it's being recorded right now. So yeah. Don't worry, guys. It will be recorded. You guys can watch the recording back at home as many times you guys need to, but this will be our live session. See how many people there are here. Right, I see some familiar users from last workshop, so welcome back. And yeah, I think we could get started. So welcome, guys. This is the second BDAA workshop. Welcome back if you guys came to the first one. It's going to be the same presenter. It's going to be me and Palak, and we are going to go over Python part 2. So this will be building on Introduction to Python course. Yeah, so it's fine if you guys haven't attended the first one. We're just gonna assume that you guys have basic foundation of Python and at least know. And feel free to ask any questions if you guys are lost during the presentation. Hello, Ava. How are you doing? I see you in chat. Okay. Yeah, so we'll be dealing with a Python library called pandas. If you guys don't know what libraries are, they're kind of like code that other people have wrote. And so instead of us writing the same code over again, you get to use and steal their code for free. And so sorry, guys. I don't know what to do. And so it's what the great thing about Python is that there's a lot of libraries that are free, that other smart people have give us, and that we can use it import it to create cool stuff. Yeah, so for Python, I think for other languages, you do have to import your library into the program's memory every time you run it. And if you guys are familiar with any of these Python libraries, type in chat if you guys are familiar. And these are libraries that are commonly used in data analytics. So we'll be going over pandas and NumPy, but you guys might be familiar with matplotlib, TensorFlow. TensorFlow is mainly dealing with abstracts, matrices, and scalars, and matplotlib is graphing. And pandas we're going to use kind of creating data frames, and NumPy is again using arrays and stuff like that. So yes, matplotlib is very cool. I agree. And you guys let us know if you guys want to learn about matplotlib, but today we'll be sticking with mainly on pandas and NumPy, and you guys will see some nice data visualization with it. So we'll be starting with pandas. And again, got a preface, but you guys can go on Google Colab. And that's kind of the way that we kind of teach our lectures. Or if you guys already have Python installed and you see your own Anaconda or Jupyter notebook, that's fine too. Things with Google Colab is that you don't import anything; it imports by itself. So if you are just recently installed a Jupyter notebook, just recently installed Python, you might have to type in your command line to install pandas. So this is the line you would type if you are using Anaconda, and this would you would type using command line. And if you guys don't know what I'm talking about, don't even worry about it. If you use Google Colab, that'll be totally fine. What you're gonna do now is just type import NumPy as NP and import pandas as PD. And what it does is that it imports both libraries as variable NP and PD, and later on we'll be using the modules and the functions within the library. And yeah, so I'll hand this to Palak and she'll explain a little bit about indexing and slicing.
Awesome. So now let's take a little bit of a look at indexing and slicing. Specifically, this is a little bit of a review from last week, workshop, but specifically for indexing any word that we have that has a bunch of different characters. Let's say we had the word happy. We all know has 5 different alphabet letters in coding language. It has 5 different characters in it. So HAPPY, and that can be referred to as the length. So the length of this string, if we were to set it happy, would be 5. But at the same time, the index of each character actually is not 1, 2, 3, 4, 5. It doesn't go and start at 1. Instead, it starts at 0. So as you can see in the first cell for this section, happy, the H maps to 0. So it has an index of 0, and the Y at the same time has an index of 4. So always remember to start at 0, and then it ends at or increments by 1 from there. So if we look at the next cell, you can see that if we have another word, let's say hello, for this string, again, the H has an index of 0. And say you wanted to reverse the string. You had a really long word, let's say supercalifragilisticexpialidocious, that's a really long word. And say you wanted to get the second to last word, second to last character. That would be really hard to do because you'd have to count up everything and you could make mistakes. So instead, you can use -1 to go at the very end of any, to get the very last index. So -1 would map to the last character in that string, and then -2, -3, going from right to left, and so on. And one way we can receive and get any of these values is by using square brackets. And let's take a look at now slicing. So another feature that we can do with our brackets is slicing. So as you can see in the comment right above, you can actually get multiple characters, not just one every single time. So the syntax for it is the start with a colon, stop with a colon, and step. So start, stop, step is essentially used to grab different characters. Start is the initial index that you want to start with. Stop is the index that you want to go to, but it will not actually print out that value, so it's not inclusive. And lastly, step is your jump size, which really just means the number of characters you want to increment by. So you can say 1, actually that's the default. So if you don't say anything for your step size, it's default to 1. So let's take a look at a few examples. When we have, let's say 2 strings, my string and flower, for my string, which has a, if we try to get the second character, notice how it's not going to say I, which conventionally we would think H is 1 and I is 2. But on the other hand, it's actually H is 0, I is 1, and then Y is 2. So you would get Y. Say you said my string of 7, you wanted to get the 7th index character. In this case, notice that the spaces also count as an index. So you actually will get the output of E. Now say you want to reverse this string or get the reverse of the string. So if you said -8, it's going to go to the very end and then increment backwards. So -1, 2, negative, or -1, -2, -3, so on to -8, receiving and outputting Y. Same thing if we said my string of -4, it's going to go from the back and go up to the 4th character. And then now let's take a look at slicing. Before I move on, if you have any questions, feel free to throw them in the chat. But now let's take a look at slicing. So we have another string, which is now called my string again. So yes, Ava, the link to this notebook is sent right above your message, actually. Feel free to take a look at this and follow along if you like. So this is the entire alphabet my string is. So now if we are to scroll down a little bit and start pulling different parts of this string apart, as you can see, for the first print statement, we're just printing out the whole string. And the second print statement, now we have the different syntax. So we have the colon, colon, and -1. So it's going to basically reverse this entire string. As you can see, it's because we're starting from -1 and going all the way to the front. And now if we said, say our step size was 2, now we're going to again start at 0, which is the default, 0 in the sense the starting, whatever the start of the word is, so A. The stop here is also at the end, again, default. And since we have a step of 2, it's going to skip every other letter. So A, C, E, and so on. Now, if we look at the next example, you can also start at some other value. Say you wanted to start from the second index, you can do that too. And then if we look at the next example, you can start again at the second index. But this time, say you only wanted to stop up to the 5th index. So if you notice, we know that C has an index of 2. That means D has an index of 3, E has 4, 5 is F. But if you look at the actual value we get when we say the start is 4 and the stop is 5, we don't see the F character, correct? That's because, again, remember, stop is not inclusive. So the 5th index, which is F, will not be printed. So we stop at E. And let's look at the last example for now. This, again, just shows you another way of, say you want to pull out the characters H and I, you can do so in this format as well. And that's a little quick overview of slicing and indexing.
Yeah, so kind of cool fact is that you can't go out of bounds with slicing. So you could put like 1000 and it's fine. So we'll go into data frames, and that was kind of the slicing indexing. Kind of touched that upon last workshop, but today we'll be talking about data frames, which is very new. Yeah, so we're gonna import random, and what random is that is it's kind of like a randomized function of a matrix. And what we're going to do here right now is we're going to get a seed. And what a seed is that it gets the same random numbers no matter where you are. Usually when you call for a random function or you ask the computer to spit out a random number, it's actually not that random. It's basically an equation, a mathematical equation that like pumps out some kind of output that seems random to humans, but there is an equation behind it. And what C does is that it say, okay, we want random numbers, but we want the same numbers. So for here, just put any number and you'll get the same seed, which gives you the same random numbers. And what we're gonna do here is that we're gonna populate a data frame. And so in order to create data frame, you do PD, which is, we called it PD when we imported Panda, dot data frame. And then we're going to input 2 parameters. So one is the numbers, and this is a bunch of series. And then here we're going to do the labels. So as you can see here, again, ABCDE is the index. It's the names of the rows, and then here WXYZ is the columns, and brand N54 populates all of these values with random numbers between certain number. And so, of course, great about this is that you could always run. Okay, so you can run it. You don't need to print df, just type in df, and it will output a beautiful table here, as you can see. So that's the beauty of pandas. It's very easy. Again, you don't need to code this. You just need to import Panda, and that's why using Python and pandas is so beautiful for data scientists and analytics. Yeah, so we'll go on into indexing selection. Pass it along to Palak again.
All right, so we just looked at indexing and slicing in normal Python just with strings, but now let's take a look at how that works with data frames. So you can actually grab certain series of objects or certain values if you want. So really quickly, let's just print out the data frame, and that's what we are actually looking at now. It's another shorthand of our table. And now to get a specific value, what you can do is you can say the data frame dot at. These are already methods that are built in thanks to Pandas, so we can refer to them. And the first thing you want to do is put the name of the column or the row that you're looking at. And then that's also known as the position. And then what you want to do is put the name of the column you want to look at. So right now it's as highlighted, it is looking at row B and column W, and then we'll print out that exact value. Now say you want to get the entire column. So what you can do is instead of using the dot at method, you can just actually use the bracket notation. And this time just put in the column name. And in this format, you'll get the entire list of all of the different rows that are associated with that column. And notice that here, if you actually use this type method that we've actually talked about in the last workshop, it gives you the type of whatever you're passing in as a parameter. Here, the type of the data frame of column W, it's not a data frame anymore. It's actually a series. So that's just a quick little note to remember that any column, each column is filled up with series. But if you go to the next cell, you'll see that this data frame, if we ask the type for it, it's actually a data frame itself. So just note each column consists of series, and each data frame, the DF itself is a data frame. All right, so now let's look at the next cell, where what we can see is you might have seen the syntax in the past where you use the dot or a period. So the name of the data frame dot the column name. This is very commonly seen in SQL or other languages, but it could be confusing, and we'll see that more later. So we technically like to avoid this method when using pandas, and instead it's a lot easier to use the bracket notation. Now let's go to the next cell, and I have a question for you guys. So if you were to try to get multiple columns, when you type in df of w comma z and try to print out both of these columns, what do you think this code segment will print out? Any guesses at all, or totally okay? Great. So Ava says that there will probably be an error because you're trying to get row W and column Z, and that's correct. So there is an error in this case, and instead, if you're trying to get two different columns, you can't just use the syntax of something comma something else because it reads it as row comma column. Instead, what you want to do, specifically if you're trying to print out two different columns, is if you look at the next cell below, you want to use a nested bracket as shown. Yep, so there's the error that you will get, and now you want to go ahead and instead use nested brackets. So this way, you actually will just get the two columns that you're looking for. Now, also, let's go ahead to the next cell. So one thing you might be wondering is, what is the type of this this element that we're passing in and printing out, the W comma Z columns? Note that these are actually data frames. So even though W column itself is a series and the Z column itself is a series, now that you're requesting two different series, it actually has the type of a data frame now. So that's another little nuance that you might want to know for future reference. And now let's go on to how to create new columns.
Yeah, so basically, if you guys are confused, data frames is just a bunch of series stacked on with each other. So each column is one series, but we add them together. It's called a data frame. And so in data frame, sometimes you would want to create a new column. Say you want to add WZ together, or you want to remove Z. You look at W. So it's very important doing database management. So in order to create a new column, it's actually fairly intuitive. You could just add W with Y and then have that equal to df equal inside, put in your new column. And again, it will print this out as a new column. And here's a question: what will this print out? DF old column. Does anyone know? So the question is, could you instantiate a column without any values inside? Have been the answer? So do you guys think you guys can create another column without inputting any values? It's fine if you guys don't know, we're just guessing here. All right. So for data frames, you actually cannot create new column without values. So it's very important for you to have it equal to at least some type of value, or it will think, okay, it's trying to locate a column, but doesn't exist. It doesn't know that you're trying to create one. So it's very important to have some sort of values in it. As you can see, if you want the entire column to have one constant value, you could put 5. Just a heads up, I know the problem with pandas is that there's many ways to do the same thing, and it can get confusing. Just make sure, remember to whatever method you use, as we'll talk before. And again, when we talk about adding and merging and joining, there's many ways to do the same thing. Just be careful with pandas is that there are certain rules that seem like it should work and it doesn't because it overlaps with other syntax. Okay, so let's say you want to drop a column. Say, okay, I really don't need a certain column. So we don't want X because X is not as cool as W, Y, Z. And the thing is, you can't drop a column just by putting X inside drop function. It actually leads to an error. Instead, you need to change it to the axis of 1. And the reason why is that pandas would be confused. So you could either drop a row or you could drop a column, and sometimes it doesn't know which one you want to drop. And so what the axis does is that it specifies which axis you want you're referring to. So axis 0 is the rows, axis 1 is the columns. So in here we're saying, okay, drop X and axis equals 1. So at the column side, and then you press enter. Yes, it disappeared. X is no longer here. There's a catch. So yes, we dropped it here and this beautiful table that exists, but it's not permanent. And as you can see, sadly, we put input here, df, X is still there. And that's annoying because we don't want X to be there. So what do? So there's this new parameter that allows us to have X to be removed permanently within the original data frame. And that's called in place. And so if you put in place equals true, it removes the column. So in this case, we're removing new col because we changed our mind. X is cooler, new col is not as cool, and we want new col to be dropped permanently within the original data frame. And so again, in place is true, so then the changes are made within the original. Again, you could do this with rows. So as mentioned before, the default axis is actually 0. So it assumes if you just put, a name here, it assumes it's a row. So you don't have to put axis to 0 if you want to drop a row. And then it drops E. But guys, is this permanent? It's not permanent because we don't have it in place. So the reason why it's not permanent is because sometimes you just want to see certain data, but you don't want to change the original data. So that's why every time it does not drop and you'd have to kind of use in place. But again, if you want to see these changes in a different data frame, you could just put a different name here, like cookie, and then there you go. So now it's saved under cookie. And so now your changes are put into another data frame and you can reference cookie another time. So the great thing about this is that you could look at its shape as well. as you can see, the shape is 5, 5 because we added a column before. And here, I don't know if you guys are familiar with matrices. So 5, 5 is the way we kind of reference how big a data table is. So it's 5 rows and then 5 columns. And sometimes you'd want to know shape. So this is very useful in knowing the shape as well. And then sometimes you want to select specific rows. And there's, again, a lot of ways you could do this. You can use the .lock function, or you can use the .iloc function. And remember, when you use .lock, you use square brackets. So you pass it in as a row like this. And then if it's a .iloc, you can pass in numerical index values. Here, I'm going to give you some examples. So this, you would locate C. And as you can see, it prints out W, X, Y, and Z over here. Sometimes though, you either want to reference it by index because you don't know what the name is. And so that's what the .iloc is for. It's referencing for the index. So as we talked a bit about here before, what is the index of C? Index of C is, again, it's the third row, but for indexes, you have to subtract 1 because index starts with 0. So yes, Alec, you're right, it's 2. So 0, 1, 2, you locate it here, and again, does it print the same thing? Yes, it does, because column 2, index 2, sorry, is the same as column C. And so there's 2 different ways you could reference it by the row name, or you could reference it by the index. And so that's kind of 2 ways we could go about this. And again, there's some just view. What does this do? It drops old column. So now we're in the OG WXYZ columns. We've dropped it, and of course, in place is true, so it changes in the original. All right, so we'll get into subsets of rows and columns.
Awesome. So now, first off, let's just see what our data frame actually looks like. And first thing we can do is using the .iloc method, we can just pass in any row or column that we want to look at. So in this case, let's just take a look at B. Now, say we wanted to take a look at a certain part of this data frame, not just one single series. Instead, I wanted to look at both the B and Y, right? The B and Y, that row, that value. So let's see what that does. So first off, if you go ahead and say .lock of BY, it's just going to give you the actual value in that location. Now, let me ask you this. What do you think would happen if we say reversed it and said Y, B? All right, so switching up the syntax, would that make any difference? Would Python be able to figure out that the Y row doesn't exist or the Y column where it exists, or would there be possibly an error? Any guesses? All right, so I have 1 response in the chat. I have now 2, and you guys are correct. So there will actually be an error. And the reason is the formatting and syntax of .lock is actually row, column. So that has to be the formatting that you have to pass in as well. So if we run that cell, if we run both cells, you'll notice that you'll get an error. So that won't work. But now let's say we wanted to get, let's move on to another topic. So say we want to get multiple rows and columns, correct? So say we want to go from both A, B, and also get the columns Y and Z. Here, if you scroll down, you can see the actual output. when you use the .lock function, it's going to give you the rows A, B. And notice the difference in the syntax. We have a colon and with no nested brackets. On the other hand, for the columns, we have a comma with nested brackets. So the difference really is that, say you're using the colon, that means that you want every single value, every single row or series that's in between those two parameters. So everything in between A, including A, B, and everything else in between. Versus when you use the nested bracket and the comma, what you're saying is that you want the column W and only you want only the column W, and you also only want the column Y. So if there's anything else in between, ignore that. That's one syntax feature that you may want to remember. So now if we scroll down, what you can see is that, say we switched up the way we wrote, say we didn't use the nested brackets or the comma, it will actually print out the X column as well. Now let's take a look at, say we used A, comma, C, all within a nested bracket. So in this case, it's just the other way. Since we only want the row A and the row C, that's all we're going to get. So B does not get printed. Now, if you scroll to the next slide, notice that there is an issue with syntax. So if you say instead of using the comma, you use the colon, that will be an error, because whenever you use these nested brackets, you're saying you want specific columns. So you can't necessarily slice using the colon in this case. If you want to do that, take away the nested brackets. So the correct way of doing this is shown in the next cell. So you would just say A to C with the colon and then W to Z or W to Y.
All right, so now we'll get into conditional selection. All right. Say you only want to see values over 0 or a certain number. You could actually do that. So you could do df is greater than 0. Of course, very simple, very easy. And it will return a true, false, a Boolean data frame. And so we kind of could do a lot of cool things with this. We're going to instantiate this as a variable, and then we are going to use it to change the data frame. And so in this case, for all of the false values, it's going to be changed into NaN. So does anyone know what NaN stand for? It's also could be null if you do Java. So NaN stands for not a number. Yes, it stands for not a number. And as you can see, look here, although false, it turns to NaNs. And say we don't want, and then you can see here, creating a data frame. This is the same thing, except instead we just use the variable. The variable equals this, so it's the same thing. And we could check this using series. So as you can see, we could check it using only in column W. True, false, true, true. And say you don't want to take, or you don't want to see all the NaNs, you can do this. So you can put a data frame of W bigger than 0, and then put that as a data frame, and then they remove all the rows that are not true. I mean, all the rows that contain NaN. As you can see here, C as values of NaN, so removed. And you have this clean table. And then you can see here, this is, other ways. Instead of, doing this in 2 parts, you could, create a data frame, have it, let's say we want to look at a condition that's bigger than 0, have that inside another data frame, and then we're going to look at the column of X, and that will return the column values of X. So again, you could layer it into one line, and that helps with code. And then we could do multiple series. So again, as Palak said before, you could reference multiple columns and print them out. And so this way you could reference X and Z. I'm running it to make sure it's right. Okay.
All right, so now that you can do simple selections using conditional statements, that means that let's see, we can also actually do multiple conditionals as well. So say you want to not only see when the W column is greater than 0, but you also want to have a condition for the Y column. And you can do that very easily, actually. You guys may know in Python, we use the keyword and if you say no other languages, say Java, we use the double ampersand symbol. All of these all stand for the same value, which means something and some other thing, but two different parameters. When you're using and working with pandas in Python, you specifically want to use the single ampersand. So that is the syntax you want to use. And in this case, all you're checking is whether the W column, all of the values that are greater than 0, and then for the Y column, all of the values that are greater than 1. And you want to actually set that in as a parameter, and then you will get that, that specific conditions, both of those met and will be printed. On the other hand, say you want to use the OR operator in a similar case as the ampersand, the and symbol, what you can do is use the single straight line that's located right under your backspace key. Instead of writing the word or, and in Java, you use two of these, but two of these straight lines, but instead in pandas, in Python, you specifically want to use just one for this specific case. And then it's going to say either meet this condition or the other one, and we'll print out the data frame accordingly. All right. So the last thing for this section is that say you want to get the indexes of your data frame itself. So you can just use the .index method, and it will actually just give you all of the indexes that you have. So right now, all of your indexes are actually the values of your rows. So it's just going to give you the index and the actual data type, which is an object.
All right. So now we'll look into missing data. So a lot of times when you're collecting data and then you're going to analyze it, you might have missing data. So this is very common, and Python has ways of kind of accommodating to this. I'm sorry, Panda. So we're going to create a data frame with D. In this case, D is a dictionary, and np.non is not a number. And so this will create kind of holes inside our data frame. As you can see here, there's holes in our data frame. It's not complete. And in this case, when there's holes in your data frame, you kind of want to take those values out. So Pandas has a neat way of doing this, and that's with the drop NA. Again, it's not in place, so this is temporary. But as you can see here, these two rows are gone. And even though there's values in each of these rows, they're still NaNs, and so they get dropped off. Again, so it's kind of similar logic as before. Axis refers to whether it's a row or column, and for this, axis is 1. And then it drops all of NaNs right into the columns, as you see here. Again, NDF, it's not in place, so it doesn't change. And then we go into thresh argument. So sometimes that you kind of want, some no values to be dropped, keep others. So thresh is a good way of keeping some but removing others. And then fill NA is used to fill missing data. In this case, we're filling all of the NaNs with fill vol. You could put any word in here as you'd like, and it will fill it for you. And so this is useful. Let's say you want to fill it with the mean. In this case, we're filling column A, last row with 1.5, and that's the mean. And then you could fill the mean as here. So it looks nice and pretty now. And so we'll go into group by.
Awesome. So group by is actually a very useful feature from Pandas. So let's take a look at a new data frame that we're going to create called data. And in this, it has a list of a bunch of companies and their sales and employee names as well. So now what we can do is go ahead and scroll to the next cell and see what that actually looks like in code. And the visual representation is right in front of you. Now, what group by really does is it merges different rows that have similar indexes into one. So as you can see, there are two different rows that have the value of Google in terms of company, that specific column, and same thing with MSFT, which is Microsoft, and then Facebook as well. So what we can do is use the group by method. So if you go down and say group by of the name of your data frame dot group by of whatever column you would like to merge, you're going to notice that this actually returns a reference to your actual data frame. So this is very useful in general, but you are going to have to do a little bit more with this. So first off, one thing you can do is set that entire feature into a variable itself. So for now, let's name it by comp, and that's all equal to the reference point of your merged data frame now. So now let's go ahead and print out by comp. And what you'll see is that it's still pointing to the data frame just as a reference. That may not seem as useful, but what you can do with this is really helpful. So let's go to the next cell and just print out our data frame. Notice that nothing actually changed in the data frame actually. But what you can do is now using our variable that is now stored and now point to our actual data frame. What you can do is now call different methods on that. So you can find the mean of all of the different companies that are combined. So in this case, it combines all of the different instances of Facebook, Google, and Microsoft. And notice that the actual non-numbered columns will be ignored. So say Facebook didn't have a value for one of the different columns, that's okay. It will just ignore it and still carry out the functionality. Now, if we wanted, we can also find the sum. So that would just look like whenever you use the dot sum method, and it would just find the actual total. You can also find the standard deviation by dot std method and a lot of other features. You can feel free to explore because there's a lot of different methods that you can use. For now, let's take another look at an example of using the dot log. So here what we're saying in cell 101, we're saying of our variable, which is currently pointing to our data frame, find the sum of the location of Microsoft. So what it's going to do is give you a quick little snippet of the actual values that are associated with that value Microsoft. So in this case, it's going to give you the sum of the sales along with the actual name and the data type. So this information might be really important based on what you're looking for. And now one thing I want to point out is that the reason we're using this variable is so that your actual data frame is not changing. So you never want to directly change your data frame. So that's why I always use a variable that would point to it, and then you can change up any values you would like. Now you can also do all of this in one line. So instead of using a variable, you can say your data frame dot group by of whatever column you want, and then the same functionalities you can carry out as well. So now if you say wanted to get the count of how many times each element in say the company column appears, you can use the dot count method. You can also look at different names. So say you wanted to find the maximum, like say you had a bunch of employees for a certain company and you want to find which which employee actually earned the maximum sales for that month, you can do that as well, which is a really helpful feature. So in this case, it's going to actually print out both the names of each employee and the actual sales. And it's going to do the same thing if you say .min, it's going to give you the minimum. So this is really useful in the future if you want to get more involved with using pandas. And the last thing that we will really talk about for this section is the .describe. So this gives you all of what we talked about and a lot more, such as the count, mean, and standard deviation, minimum, maximum, and then the percentages at 25, 50, and 75. All of this breakdown into a nice little chart for you. So it's a really useful feature if you say want to get a quick rundown of all the numbers. Now, if we scroll down, you can also see that you can see all of these values for in out in a different format by using the dot transpose. So that would be really useful. Say if you wanted it in a different fashion. And now if you say wanted to look at the actual values and all of this data broken down for specific companies, say Microsoft, here what you can do is you can take a look at everything. But in the next cell, you'll notice that syntax is very important when you're actually referring to this data frame. So you can't say and use the .describe simply as is. You would need to use the .transpose as well. So let's just go ahead and print out our final data frame and notice that nothing is ever changed in it. But the .group by really helps you analyze and collect a lot of the information really efficient. All right, now let's talk about merging, joining, and concatenation.
Yes, so sometimes you want to add your data frames together. And so there's tons of ways of doing this. So right now we're going to instantiate 3 data frames. These look a lot of data. Really gonna work with more data. And we're just gonna kind of put them out and see they create these beautiful graphs. And let's say we want to add all of these together because they have A, B, C, and D, and they're the same, and we want to add them all together. So the great way of doing this is using concat. So concatenation glues together data frames. And what you want to be careful is that the dimensions should match. So in this case, you want the columns to match. And so you can use p.concat and concat them together. And so you have this beautiful baby that has all of the values together. Just look at that. And then you could concat them in different ways. So this way, we're concatenating them with terms of rows. So you look at here, all the rows are added, the columns are the same. If you want to concatenate axis wise, again, it's going to create this mess. And the reason why it's creating this mess is because none of the rows are the same, none of the columns are the same, but we're saying we want to add them to the columns, so then it just adds here, and then you have all these missing values all the way here, and just see here, all of the values that we have are right here, but it's missing values. And so here's review. How would you want to fill these null values? And we review this from before. You just want to fill it with empty. So we're going to say, okay, these are all the empty values. And if you want to, drop them right here, it will drop all of them. It will drop all of these rows because none of these rows has entirely filled values. So it will turn an empty data frame. Okay, here we're going to create some new data frames left and right with keys. And then this is going to be a bit more complicated and we don't have much time left. I entered a link here and there will be a link here as well. So merging is kind of the same way, except it kind of goes on into like how you want to merge it based on what column. And so here we want to merge all of our matrix or data frames by the key. And so again, it merges all of them here. And so instead of creating, these keys again, it merges. So then it'll share the same keys perfectly here. Sometimes though, you want to have multiple keys. And so you can merge them in different ways. Again, merging them to make sure the same keys are the same, or then we can merge them right how outer, right, left, etc. And here's a link kind of describing how you would merge them. So left, you would merge them with the keys from the left frame, right frame. And there's examples here as well. I don't want to like go over time. So if you guys are interested in this, just check it out. It's pandas.pydata.org. And here's just some examples. And with joining, it's the same. So you might be confused, what's the point of using joining if I know how to merge? Joining is more simpler and merging has more options with how you want to, merge them. Joining is pretty much the same. You want to create left to right data frames and then you can just join them. So if you guys are beginners, I would suggest maybe first use join, or you want to just jump into merge. That is fine as well. So there are multiple ways on how you would want to, put together two data frames, and just make sure to check it out in your free time, kind of look more into it. It's very interesting, but we'll move on. Again, what's the difference between join and merge? There's not much of a difference. Merging just has more parameters, so there's more options on how you want to merge them. Yeah, so check out merge, join, and concat. Very interesting, but we'll move on to operations and finish. So you guys can end.
Awesome. So let's move on to the last section now. For the first cell that we'll look at is basically just the .head method, which what it does is it gives you a list of the top 5 rows, top 5 important information that you would want to look at in a data frame. So use that as you need. And now one other thing you can use is the .unique method. And what this does is say you have multiple values in your data frame, you can filter all of them out and get a simple array that has just one copy of every element that is in that column. So that's a really useful method if you want to use that. Another thing you can do is actually find the length of this as well. So if you need to say find the number of unique actual values in a certain column, feel free to use the len method. And another useful method that you can use is the .nUnique. And what this does is the in cell 137, where you see where we use the length and the .unique method, you can actually combine all of that into one. And actually, Pandas has this one method called nUnique that does that all for you. So it's going to give you the length or the number of unique values in that specific column. Now let's also look at how you can see the number of times values appear. That's just by using the .value count method, and it just gives you the amount of times a certain value actually appears. So you can filter your data that way. Now looking at the next cell, this is just printing out your data frame. Really quick overview again of your conditional selecting. So if say, even though you have multiple values, you can say in column 1, I only want to look at those values that are greater than the value 2. So it's going to only show you specific columns, such as in this case, the 3rd and 4th, according to column 1. Another thing you can do is get your Boolean series, which we've also mentioned before. And in the next cell, you can also see how you can use multiple conditional selection by getting by putting different parameters and using either the and symbol or the or operator, which is a single straight line down which is located right under the backspace if you need to. Another really useful feature is using the .apply method, and this actually lets you apply anything you want onto whatever column you specify for that data frame. So in this case, I created a simple method which multiplies every value by 2, called times 2, and it takes in a parameter and just multiplies that parameter by 2, and you can apply that function onto your actual column. So you'll notice that the data frame originally was not 2468, but or that series was not 2468, but currently it changes that value. So another thing you can do is actually apply the length function. So this really just shows you that the apply method itself has so many different use cases. So you can use your own functions. It can be applied to different built-in functions. So that's a really useful feature. And really quickly, I wanted to talk about Lambda as well. So right above, we saw how to create a function using the def keyword with ×2. But now there's actually an easier way to do this. So Lambda, think of this as a shorthand form of creating your own function. So you can say Lambda and say whatever value or parameter you want to pass in. So in this case, you want to pass in the BAR, and this will just be a variable that stores every value that you want. And with a colon, this now says whatever comes after it, you want to actually carry that functionality out. So it's going to take every variable and multiply that by 2. So that's exactly what we're going to do to column 2 in this case. And our now new function will be applied to column 2. Notice how the values have changed. Now, I have a question for you. What do you think this new column or this following code segment will print out? Say if I said df.drop col1, do you think this will actually drop your column, or will there be an error, or will it work completely fine? Any thoughts? Feel free to put them into the chat. All right, so with the interest of time, I'll give you guys the answer, but this is a review from before. This actually will result in an error, mainly because your column is actually a column value, not a row value. So it's actually not found in the axis, which is currently default to 0. So in order to fix this, if you scroll down, you can notice that you can just fix this by putting in your axis of 1, and then it will go ahead and drop that column, but it's not in place, as you can see. And the last 2 things I wanted to talk about for now are the fact that you can actually get your columns in a nice orderly fashion by saying the data frame name with the .columns method, and then you can do the same thing for your indexes. And notice that in this case, the indexes gives you the range of all of the values that are in your index. So in this case, you'll notice that it gives you a start, stop, step. So that means that it starts at 0, stops at 4, meaning it really just goes up to 3. And steps by 1, so you have an actual index of 0, 1, 2, 3. And that's pretty much all we have for today. We hope you learned a lot and really enjoyed learning more about pandas and Python. Drop any questions you have in the chat, but thanks so much for coming.